for number 5, we are required to differentiate this function. Now, the approach that you can use in this case is by applying laws of logarithms. And what I'll do is to use laws of logarithms to rewrite this equation. So we have y is equal to ln of this. Now, by laws of logarithms, this can be written as ln of x squared minus ln of x plus 2 multiplied by x minus 3. And this can also be written as ln of x squared minus ln of x plus 2 minus ln of x minus 3, because this is basically a product of two expressions which can be written as that, and then of course you multiply each of them by the negatives, because this is same as ln of that plus ln of that, and then you multiply by the negatives. All right, so after rewriting the function that way, we can be able to now to differentiate term by term. So dy over dx will be equal to, now one thing you have to notice here is I will apply chain rule for each of these uh, terms. So the first case, if you apply chain rule, the derivative of x squared is just 2x multiplied by 1 over x squared, because the derivative of ln x is 1 over x, and our x happens to be x squared. Minus, same thing here. This will just be 1 over x plus 2, because derivative of x plus 2 is just 1. And here we have minus 1 over x minus 3. So the resulting expression will be 2 over x, because the x cancels, so 2 over x minus 1 over x plus 2 minus 1 over x minus 3. And that will be the required solution. Okay, number 6, find the derivatives of these functions with respect to x. So one thing that we discussed that will help us here is that if you have an exponential in this form, then it follows that dy over dx will be equal to a to the power x ln of a. And we can use this to basically differentiate these functions here. So in the first case, dy over dx will be equal to, a happens to be 4, so that will be 4 to the power x ln 4. And that's it. For part 2, we have to apply chain rule. So what's inside is 2x. So derivative of 2x will be 2. And then we just apply this rule here. So dy over dx will be equal to a to the power x. A is 4, so 4 to the power x, our x is 2x. Ln of 4. So you can write this as 2 multiplied by 4 to the power 2x ln 4. Okay, moving on. Number 7, we are required to find the derivative of this. This is a product of two functions, so we apply product rule. So dy over dx will be equal to x multiplied by the derivative of 4 to the power x plus 4 to the power x multiplied by the derivative of x, and this will be equal to x multiplied by, now applying the rule that I've just shown you, This will be equal to 4 to the power x ln 4 plus 4 to the power x multiplied by 1. And this is same as x into 4 to the power x ln 4 plus 4 to the power x. And that will be the required solution. Okay, moving on. Number 8. So for number 8, we have this function. Now, what we need to do here is to use the exponential rule to simplify this. And basically, this can be written as y is equal to e to power ln x squared. If you bring 2 in front here using laws of logarithms, plus 4 log to the 6 of x. Now, ln x squared is same as x squared using exponential rule. So this is same as y is equals to x squared plus 4 log to the 6 of x. So we can go ahead and find the derivative of this. So dy over dx will be equal to 2x plus, now 4 is just a constant. The derivative of log to the 6 of x, as I showed you previously, is same as x ln 6 because the base is 6. So we can simplify our solution as 2x plus 4 over x ln 6. In part B, we can rewrite this as ln x to power negative 1. So just ln x to power negative 1. And then we apply chain rule because we have a function inside and another one outside. So dy over dx will be equal to negative 1 into ln x to power negative 2 multiplied by the derivative of inside, which will just be 1 over x. So we can write this as negative 1 over x ln x squared using laws of indices, because the negative power can be brought down to have a positive power.